Here we are. We are in Math 1332. Video lesson. Chapter 2, Section 2, Homework. Let's look at the first one. Write which one of these two symbols, contained in, not contained, in the blank so that the resulting statement is true. Are the elements 3, 5, and 7 in this other set? 3, 5, 7. Yeah, so because these are inside these, we use that symbol. So it's that. If these elements were not, this is A, B, C, then we say, no, it's not an element of her. Contained in. Write these two, one of these two in the blank. So the elements 6, 32, 37, are those in this set? Only 37, 32, we're missing 6. So, which is that one. Remember, in order to be included or contained in, all of these have to be in the other. Which one of these two go in blank? The elements are red, blue, and green. Blue, green, missing red, so we can't say that they're contained in, because the red's loner, not there. Same thing. Look at that. The set X such that X is a tree. The set X such that X is a spruce tree. Now, yes, but they're backwards. We have birch, we have weeping willow, we have sequoia, but this one says X is a spruce tree, specifically one tree. So in order to be true, all of these have to be there. But since there's too many here than in there, then we have to go no. Alright, number 5. Which one of these makes a statement true? The set AB? What symbol in the set is Z, A, Y, B, X, C? So, is AB in the set? Yes. Are all of these exactly in the set? Yeah. So all of these can equal what's inside here, so it's A. That's what that, there's a difference here of these two symbols. This one means there's at least one difference. This one here, that. Everything in set A, everything is inside. It can't equal in set B. They're contained in. This one here seems to me that there's one difference at least. Number 6. The set 9, 10, 11, 9, 10, 11. So we cannot use this one because all of these are exactly in these. They have to be able to be equal. So it has to be A by itself. Alright, so that's the first page. List all subsets of the given set. Remember, what are subsets? So if we have the set AB, the subsets could be both AB, the set A, the set B. It could be both of them, either one of those, or it can be the empty set. And we have two elements. Remember, the equation is this for subsets. Since we have two elements, so we have four possibilities. 1, 2, 3, 4. And in this case, it's 7 and the empty set, so it's C. Calculate the number of subsets and the number of proper subsets. Remember, the formula for proper subsets is 2n minus 1, because you have to have at least one difference. So we have 1, 2, 3, 4. So in our example, n is 4. Number of elements in a set. So subsets is 2 to the power 4, 2, 4, so it's 2 times 2 times 2 times 2, that's 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now proper subsets is 2n minus 1. So it's 2 to the power 4 minus 1. 2 to the 4th is 16, minus 1 is 15. So the answers are 16 and 15. So it's C. Number 9. Calculate the number of subsets and the number of proper subsets of the set. What is our n? 1, 2, 3, 4, 5, 6. So subsets, the formula is 2 to the power n, which is 2 to the power 6. 1, 2, 3, 4, 5, 6. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Number of subsets is 64. And the proper subsets is 2n minus 1. So 2 to the 6 minus 1, so 64 minus 1, 63. So we're looking for the numbers 64, 63, which is C. Determine the following statement is true or false. If set A is equivalent to the set of natural numbers, then remember, this n is the cardinality, or the cardinal number, and that means the number of elements. So the number of elements of set A of natural numbers is equal to n sub 0. N sub 0 is the whole numbers. Remember, whole numbers start with 0 and go on to infinity. And natural numbers are our counting numbers, 1, 2, 3, all the way to infinity. So, is the cardinal number of this less than to the set of whole numbers, or whole numbers? That's false, because this is one number, let's say 8, and this is a set of numbers. So it's going to be false. It's comparing apples and oranges. Determine the statement is true or false. The empty set is a subset of the set of empty sets. That has to be false, because the empty set cannot contain the empty set. Because this has 0 elements, this has 1 element. So remember also, the set of empty sets cannot contain itself. And let's look at number 12. Consider the accompanying branching tree diagram. The tree diagram begins with a seed, and it sprouts. And from each one of those, they sprout more leaves. So consider the branching tree diagram based on number of per 3,000 American adults. Let T, the set of Americans who like classical music, R, Republicans who like classical music, D, Democrats who like classical music, I, Independents who like classical music. Determine whether the statement is true or false. I is an element of T. I is a set of Americans who like classical music. The set of Independents who like classical music. Is that true or false? So 1,500 Americans who like classical music per 300 adults. So we have 635 Democrats, 511 Republicans, 354 Independents. Is this a true statement? But remember, what does that mean? Is an element of. So, are the set of Independents who like classical music an element of the set of Americans who like classical music? You can't be for sure. Those Independents may not be Americans. Oh, that's it for section 2. All right. Good luck.